Good day to all. Today we are going to see about that hydraulic system. See, these are all the example of that hydraulic system. This is one of the example of hydraulic system. Then how it will occur like this. What is the hydraulic system? You can see that introduction of that particular hydraulic system. What are all the hydraulics? The study of the mechanical properties of the fluid is called hydraulics. And what is the fluid power? See, the useful of fluid motion under pressure to transfer power and energy from source to sink. This is the fluid power. The normal definition is for that hydraulics is the transmission of power from a power generation source to sink using engineered incompressible hydraulic fluid for sake of creating leakage and motions. The pneumatics is nothing but the transmission of a power from a power generation that's source to sink using pressurized air compressible as the fluid for sake of the creating leverage or motion. What are all the elements of fluid mechanics? See, these are all the main elements of that fluid mechanics, which is Q, P, V. Q is nothing but fluid flow, the volumetric rate gal per hour and L per minute. Then fluid pressure P, force per square area, lbs per square and kg per square meter. Then V is nothing but fluid velocity V, which is a distance over time, feet per second, minutes per second. Then the fluid temperature T, it's Fahrenheit degree or centigrade. Then fluid viscosity small v, the fluid resistance flow CST centi-Stokes. The relationship of that fluid mechanics or which with for fluid flow and velocity is nothing but, see here, Q equal to A into V, where Q is volumetric rate, A is cross-sectional area and small v is fluid velocity. The fluid flow is a system is additive. We can see that Bernoulli's law of incompressible fluid is nothing but H is equal to Z plus P divided by rho G plus V squared by 2G, which is fluid is flowing with a significant difference in height between source and strength, where H is equal to total head pressure, small v is fluid velocity and G equal to force of gravity and Z equal to the height of fluid source. P is equal to fluid pressure and rho is a fluid density. These are all the fluid mechanics relationship. And P naught is equal to P plus V squared by 2, which is fluid height is insignificant, where P naught equal to total system pressure, P equal to static pressure, V equal to flow velocity. If we want to know about the total pressure, then we have to use that particular formula. Then what is the hydraulic fluid power? Fluid power depends on a viscous fluid flowing under a pressure from sink to source. The system's efficiency is dependent on fluid density, temperature and pressure loss due to decreased fluid velocity. So you can see source that will create pressure and fluid flow viscosity has a velocity and it will go for sink. This fluid pressure energy into leverage. The gravity as well as change in temperature will occur when the fluid flow will come there. We can see the overall view of that hydraulic system here. See, the tank is here. From the tank, the pump is connected with this tank and the relief valve is connected with that pump. This pump have a external electrical connection, and this relief valve control with that control valve. This control will valve will operate that particular cylinder, this piston, whether it will go from here to there or there to here. If it is retraction or extraction, that will happen with the help of that flow control valve. Again, the oil will go for filter. Then this filter will go up into cooler. Why it will go for cooler means this pressurized oil have some percentage. The oil is very heated, so it should be cool before it going to the tank. So this is the overall view of that hydraulic system. Then this is the typical motor power circuit for the other way of that hydraulic system. See, before there is a normal pump, but here you can see it is a variable pump. We'll have a external connection with servo control valve with the joystick. We can use the hydraulic motor because see, you can, if we are going for normal pump, we cannot connect with that hydraulic motor here, whereas from here we can connect that hydraulic motor. This is the advantage of that typical motor power circuit. We can actuate that hydraulic motor. It is connected with the blower fan. This blower fan will rotate depends upon that pressurized oil will come from there, then it will rotate. This is hydraulic motors overview. The main purpose of this hydraulic motors or the hydraulic motor converts the hydraulic energy. So you can see hydraulic energy from pressure into rotary motion and torque to drive a implement or a system. This hydraulic energy of pressure will convert to rotary motion, which is it will help to rotate the motor. That is the main purpose of that hydraulic motor. The types of hydraulic motors are fixed positive displacement and variable positive displacement. The example of that fixed positive displacement are gear, piston, gear rotor or gear roller we can say, and van types. These are all the example for fixed positive displacement motors. And the variable positive displacement. This is the piston type 1. The application of this motor is the wheel motor have drive a mobile equipment wheels which is skilled strays and lifts. We can use the lifts. In that lift we will use this wheel motors and fan drives, hydraulic fan drives which is used to cool the engines and some industrial needs. Somewhere it is used in that industry. That's we denoted here as a industrial equipment, drive train cooling and gensets. Why we are using for gensets, if gensets it's running means it will have some more temperature will occur inside that body. So we use this type of system and the grain trials. These are all the things, the example of that hydraulic motors. The main advantage of fixed passive displacement is used. It has a very good efficiency compared to other type of motors. This variable passive displacement have also the good efficiency. These are all the very good example of that hydraulic motors. Thank you.